Next Gen Web Services with Shawn Wildermuth.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company empowering .NET teams to be self-sufficient and to deliver world-class results. And they are hiring, so you can go to clearmeasure.com/careers. They're hiring architects as well as .NET engineers who'd like a path to become an architect. And the guest on the show today, longtime friend and colleague Shawn Wildermuth. He's been tinkering with computers and software since he got a VIC-20 back in the early 1980s. And he's been a Microsoft MVP for a long time, Pluralsight, author, filmmaker. You can reach him at his blog at wildermuth.com, WILDERMUTH.com, or find out about his film at helloworldfilm.com. Shawn, welcome to the show. How are you, sir?
Glad to be here. I think I last saw you at one of your MVP parties that you ran for, 15 years or something?
Yeah, 2019.
Wow.
Well, I remember wasn't it like 1 week before that conference in 2020 when we got the cancellation notice?
Something like that. Yeah, I remember it. And it was the right thing to do in 2020. But I think everyone's gotten too used to having the summit now all virtual. And so I'm a little sad about that.
Yeah. Well, even the .NET Conf has always been virtual, but you've been speaking for so long, and I'd like to ask you about your recent talks. But for those of you who haven't seen you speak, either in real life or online, or seen your writings, can you give us some quick background? What are the high points of your career that's kind of led you up to what you're doing today?
A lot of luck. I did not take the normal career path. I dropped out of high school and college. They called it dropping out, but I was finished with college after a year and a half. And I was just lucky to get jobs when I was pretty young before, they really talked about needing degrees and all that. So I've just been doing this for forever. And I've gone through different phases of caring about the database, and then caring about the front end, and then caring about the back end. And I've always mostly been in the Microsoft space for, the last 25 years, maybe. And so I'm passionate about helping developers create projects that actually add value. Like, I think people know me more as a pragmatist than sort of the ivory tower guy. Like, I'm not going to get too involved in what is the right or wrong architecture, because in my mind, every project has its own use case and has the mix of developers and the mix of business requirements and all of that. So there isn't, this one way to do every project. And I think that's kind of where I sit is trying to be pragmatic. When I go into a company and they've got a bunch of junior developers, and you come in there and say, well, you need to learn how to do this and CRQS and all these other things. I think it can really slow down a project when they need the project to be done in order to bring in revenue to pay those developers. Sometimes, that's kind of where my sweet spot is. I don't do much project development. I think I learned a while back that I'm a better trainer than I ever was a developer. And so, and I've been writing for Pluralsight for 15 years, maybe. And before then, I was doing face-to-face training and a lot of writing. And so I still keep my hands dirty doing development, but my company, Wildermuth, doesn't do much like active project work. We do, what I call real value consulting. I'm going to come in and help you figure out a problem, and then I'm going to leave with you having the skills to solve it instead of headcount and all that other things. And
Yeah.
that's led me to a pretty lucky life. I get to learn the newest things and then teach people it. And that, I think, is, for me, much more exciting than the building of projects like it was earlier in my career.
Yeah. Yeah. You mentioned Pluralsight. How many courses are you up to now?
Well, they keep on retiring the old ones. So I'm around 25 courses, I think.
And for those listeners who don't know what that is, pluralsight.com, just go to it. Massive video library of teaching all kinds of, it at one point it was just programming and techie related stuff, but now they have so many things in the catalog. And I come across quite a few people that don't realize that a lot of companies' benefits packages include a few $100s a year for just self-directed professional development, and that a lot of people just sign up for Pluralsight and then send the receipt and get it reimbursed through the continuing education benefits at work. So check into that. If that could be a way just to get it for free, but
Yeah.
it's a great educational service.
There's the last time I remember them telling us the number, there were 7,000 or 8,000 courses on the library, and it's an all you pay one monthly service fee and you get access to all the courses. And so my 25 doesn't sound like a lot of courses when you think about the 8,000 they have up there. But it's been a very interesting thing. I came to the party late because I was like, video courses are going to, cannibalize my in-person courses. And then when I finally, sort of agreed to do video courses, when I realized how much there were destroying face-to-face courses, I was kind of late to the game. But it's something I really enjoy doing. It's sort of asynchronous, so I can, I just finished another module for a new course last night, and that way I can have my mornings free, and there are no stand-up meetings, and I feel pretty lucky because of that.
Yeah. Well, let's get into talking about next generation web services. You've done a lot of work on it. You spoke at the .NET Conf on real world minimal APIs, and you've also done some speaking on gRPC and web services. What you can do today, you have a lot more options than what you could do a few years ago. Give us the rundown on what's new, and then we can kind of dig in more detail.
Sure. One of the things that's been happening the last few years is there's been a lot of new technologies that are trying to sort of solve the website issue. REST has done such a good job of sort of democratizing APIs across so many companies. But there's still people coming in with GraphQL and other technologies, SignalR in some cases, as this is the way you should be doing it. And I avoid that sort of story because I think, much like most things in software, there isn't a right answer, right? There is. I've stolen the phrase, which obviously is wrong, but sort of polyglot APIs is the way I sort of think about them. In that, for sort of CRUD, REST does such a good job for what it needs to do. It's awesome. It's makes sense. You can map verbs to nouns. It makes sense for sort of CRUD forms over data sort of APIs. And then when you start to get into some of these other technologies, I think you're going to find a lot more projects that are using a handful of them. So GraphQL to me is amazing when you need to do reporting over that data, where you don't have structured queries, but you have a way to expose a schema that you can then write ad hoc queries over it. And I've seen people try to do that over REST so many times. OData and a myriad of other solutions. I think that GraphQL does a really good job of that. So a replacement for REST, it's so much more complicated to set up that for a lot of organizations it's just not necessary. for things like multicasting, SignalR does a much better job than we could probably invent over REST. And so using this different thing to do that part of your application. And gRPC, which I've been talking about more the last couple of years, is for contract based. So in a lot of ways, a lot of companies are using it as a replacement for like WCF, where everything was very contract based. And it's also high performance and cross platform, so that the contracts themselves define what the serialization looks like. And so if you're going to partners, or especially things low powered like IoT devices, gRPC is a really natural fit because it can handle these um, uh, payloads in a very terse way and be able to serialize and deserialize them way faster than JSON. Makes them a little harder to debug, and you have to have the agreement around contracts. You don't have the looseness you have with REST, but for those situations where that benefits, you have yet another tool in the box. And most of these sit on top of HTTP or HTTPS, right? So we're not talking about really competitive things. We're not talking about bringing back Corva or Com Plus. We're talking about distributing those APIs. The developing of those APIs ends up being similar to what we've always done, designing them so they have the interoperability and dealing with things like versioning over time and dealing with, scaling them out. One of the things that's come up out of ASP.NET 6 is this idea of minimal APIs, because we've been building APIs with sort of the MVC stack for a while, and that works really well until you get into these very small microservice architectures. Now, we can argue whether that's a good idea or a bad idea, but where they're necessary, minimal APIs allows you to build these very small services that do very specific things that work with microservices. For me, minimal APIs, which is this, again, very brief way, in fact, has a better use case than microservices, and that is prototyping as you're developing a project. Oh, I just need to mock up the API so that we can start working on so the people that are doing the front end or that are doing the middleware or whatever can start working. Let's just spit those out instead of doing the architecture for the whole thing. And then we can mature that in several ways. We could do it, where we have more structure like we would in MVC, or actually move over to MVC once we get the benefit of wanting to do smarter routing and versioning and some of the other things that are just harder with minimal APIs. So I don't see it as a replacement for MVC at all, but it's a way for us to, sort of have that smaller, quicker version. And frankly, this is what the Nancy FX was doing, 10 years ago, and Sinatra before it. And there's a few other libraries that do this sort of thing. So this isn't a new invention. It's just something that the ASP.NET team has really gone, we need this as an option as well.
Right. Well, there's so much that's gone on longer than 10 years ago. And of course, people like you and me who are around when the announcements were made and that stuff was new, we're like, oh yeah, it was just like that. I remind myself that in 2013 and beyond, about half the industry started 2013 or later, just from stats. And so they're like, what was that? Oh, yeah, I've heard of that old thing. But decompose that a little bit for the listeners, like gRPC, HTTP, JSON, and all the different ways that a running process can communicate with another running process. There's words like channels and protocols and serialization formats. You can kind of make your head spin trying to figure out what are the options. Can you break it down? What's the difference, and which things are kind of stable and we don't want to change them, and which things, hey, now there's a new option?
Sure. So I like to break it down into, I think REST is still the primary position for most designs of APIs. The way that we can use the URL to sort of self-describe the way that APIs can get at and change data, I think is very natural. There are cases where, let's start with SignalR. SignalR is a way to have communication in somewhat real time with servers and clients. And the magic of SignalR isn't that it does this, is that it does this while being able to recover from disconnection and weird networking. So I'm in a company behind a proxy server. How does that possibly work? There is no direct connection between me and that server. and SignalR tries to solve that. So you could imagine if you were writing a service that was going to send urgent news to everyone in your enterprise. SignalR is a great way to go, oh, we have this snippet of news, and make sure everyone who has a browser open suddenly gets that. That's where SignalR really makes most of its money, frankly, is this idea of having a collection of connections and then be able to broadcast to all of them. Does other things, certainly, but that to me is its winning position. GraphQL is a way to take and develop a model of your data that you want to be able to query against. So GraphQL is a graph language query, right? It's SQL, but for a graph. And so you're still having to take what in many organizations is a database, a relational data, and then forcing it into sort of a graph or a hierarchy, but then being able to write queries from the client that look at that data in a myriad of ways. GraphQL does a really good job of having a language on the web that allows that. And all of these are still, going to a web server someplace. It's just the protocol of how it does its magic under the covers. It's a little different. gRPC has the benefit of not only having those contracts and the serialization that I talked about before. Basically, all that means is that it's serialized in a binary form instead of a textual form. But it also supports unidirectional and bidirectional communication. And so I can have a stream open from a client that sends continual information back to the server or vice versa with gRPC. It doesn't do multicasting like SignalR does, but it does a connection to connection in a really interesting way. And so you could imagine, I like to talk about the IoT example of I have weather instruments somewhere on a pole in downtown, very small, Raspberry device, collecting these information. And as the weather changes, it can be beaming it up to a server that's waiting for it while being able to scale that up in a really smart way. And that's kind of what gRPC was invented for. And it just sits on top of HTTP 2 and 3 streaming protocol. So it's not inventing this thing. It's actually using it. But it does mean you have to have servers and clients that can deal with HTTP 2 and 3, which a lot of browsers aren't there yet. And so to me, it's about communication. gRPC is about communication to external devices that aren't necessarily websites, though there is a way to do that, as well as inter data center or inter Kubernetes communication, because those are contracts that you want to define ahead of time inside the data center and have as efficient as possible.
Where you control both sides anyway.
You control both sides anyway. And so you've agreed on what that looks like.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
That's a good point. I think that goes into this conversation. I'd like to know your thoughts on there. When you would think, oh, I control both sides anyway, and then where you don't. I think of this notion as compatibility or reach, and we used to think about that as websites as well. We would design the website a certain way if it's marketing or e-commerce. We want anybody of any type of computer or handheld to be able to use it versus, oh no, only my internal employees use this website, so let's just tell them to use browser A.
Right, exactly. And this is somewhat the same thing, in this sort of architectural picture I've talked about, using REST from mobile apps and from the website coming into the data center, and then the data center using gRPC inside of it. And then for notifications, also having SignalR over here. And for the reporting section, having GraphQL. And there's a handful of other APIs as well. But having this in a complex system, you may have one more of these. It's not about going GraphQL is the best thing to do all things, or that gRPC does everything in the better than REST. And I just don't think that's the case. I think when we get caught up in that winner mentality, we lose in software in general. And this is just an example of that. NoSQL versus SQL was another example of that. Is, well, I'm going to have both, because sometimes late writes are okay with me, and sometimes I need transactions. Like figuring out where these things belong is the nature of things.
Especially all the old relational only database engines. They also now support the NoSQL style as first class data types as well. So it's like, we need both. Just pick. Well, there's a lot of people out there that literally haven't even done the hello world sample of gRPC. So what does that look like? What libraries? If you open up, if I open up a JSON, packet or body in Notepad, okay, I've seen that before. What does gRPC look like? What are the libraries?
So gRPC is this open library created by Google, and there are generators for generating the services and the clients. So because it's contract based, you have to have that piece. And the central part of it that scares some people is there's a interface definition language called protobuf, or protocol buffers. Now, protocol buffers is such a bad name. It's just an interface definition language, but it was invented for other reasons, for defining interfaces. It wasn't developed for gRPC. gRPC is just leveraging it. And it's a way to define what messages and what services look like, so that a server can implement it and a client can implement it. It's that intermediate that is language agnostic, has most of the data types you're used to, but also you can extend it with your own data types, which are called messages. And the language itself doesn't imply some things you might get from languages like default values and such. All it implies is I have a data type and a message, and this is the order that they're serialized in, because the message that goes across the wire isn't self-describing on purpose. Like JSON has to be self-describing because you have to have a way to turn it into something else. And gRPC and protocol buffers specifically says, no, protocol buffers is the contract to say what the package looks like. And that's why it can so efficiently deserialize it, because it already has the recipe. It doesn't have to be self-describing at all. And so it can be very small and very quick to serialize and deserialize, because you're dealing with a third-party recipe. Now, that's not necessary in a ton of situations, but for some places, that's so crucial. Not only the performance, but knowing what that contract is, and that contract isn't going to change quickly over time. It's sort of the anti-GraphQL, right?
Yeah.
GraphQL is about there are no contracts. Just come in and query my data the way you want. It's the opposite of that.
Do you have any favorite gRPC.NET samples that we could point the listeners to?
I have courses on Pluralsight, of course, but I'm trying to think of a good example I can point them to. I will find one and put them in send it to you for the show notes.
Okay.
I can't think of one off the top of my head, but there are a few sort of interesting ones. And I have several blog posts and such I'll point people to as well that also talk about it.
Tell us the title of the best course that people can search for in Pluralsight as well.
It's creating gRPC services with ASP.NET Core.
All right.
Could not be any easier.
Yeah, there you go. So in the time we have left, with all the experience that you have, I guess this is a futuristic question. There's so much that has changed, and there's the normal way that all the documentation says to connect one process of some sort to another process and all the options. Fast forward some number of years in the future, where do you want to see web service APIs go to? Computer programs talking to other computer programs is effectively what this thing is.
It is. And it's interesting because I don't think it's going to change that much. Like, we keep on trying to reinvent it. The basics of RPC were invented in the early 70s. 1970s. I think I'm supposed to say now.
Yeah, we're in aught 22.
Yeah. Yeah. And so, the idea of how you describe a message and how both sides know about it, I think we've sort of cracked the nut of most things are going over web interfaces because those are easy for IT departments to secure, right? That's really what it comes down to is it used to be that we'd have to poke holes in firewalls and do all sorts of crazy things to make, .NET remoting, if anyone remembers that, or Complex or Corba or any of those DCOM.
Because they go across different ports too.
Yeah.
We trust port 443 at this point.
We do. Or at least a range of them that are in that range. And the protocols like HTTP have really expanded to sort of allow that. What we've learned, and I don't think it's going to change a lot, is that having hard connections doesn't scale well. And so even though we're writing code that feels like there's a definite connection, it's really not. There's really no, long-term connection. There's a way to go, oh, I'm going to go dormant so that you can scale this well. And I don't really see that changing a lot unless we get into, the esoterics of quantum computing and, who knows what. But I think the essentials of the way we communicated over IP packets when the TCP/IP first came up to what we're doing now isn't actually that different. There's shiny new packaging and someone has shrink wrapped it, but it's easier to write. But underneath, we're still just sending packets of information and relying on the network to do the right thing. And I don't see that changing.
Let me ask you about one part of it that just still puzzles me. You have synchronous blocking communication, which is the typical web service API. And then you have asynchronous non-blocking, which you think, Azure Service Bus or any of the queuing technologies. And, you can have a computer A talk to computer B to ask them to do the same thing, but just fire and forget asynchronous through a queue, or no, let me call a web service API and let me wait for the answer. And it could be the exact same question, the request for the exact same data or command, so the same contract on each side, but you're just like, you know what? I don't need it right now. I'm just going to send it over to you. When you have it, you send it back over to me. We got some queue addresses. And so with web service APIs, the normal thing is for every different request, there's a different URL that you call. But for asynchronous queuing, we just have it's normal to have one queue address and any number of these message types. Why the difference? Why does it need to be a difference? Is there really is the essence really, what should it be in your opinion?
Well, the difference for me really is about having a system that knows how to coordinate them, because there is coordination when you get into message systems. And I think your point is important to note, is that I often forget to include those in sort of the idea of using some sort of asynchronous communication is an API. The fact that it doesn't wait for a response immediately isn't important. That's one of the things that gRPC sort of brings into the table as well. So if you want something closer to that without having to set up message queues, but message queues or service buses or whatever name you want to do, those have been used as long as RPC as well. Like they're different sorts of operations. I want to reboot a server, I want to use RPC. I want to submit an invoice, I do not want to use RPC, right? I'm going to submit the invoice and then sometime later it's going to tell me whether it was accepted or not. That is perfectly fine. Now, the reason for the different URLs, I think, is more architecturally than necessary, right? Because if our messaging was really what in most web APIs, the URL is part of the message, right? When we think about a message underneath the covers, it's that whole block of a message. And the first one is, what is the URL to this, right? We think of that as the whole message. And in things like queues, that whole message is also the message. We're just sending it to the same place. And so I think it's more architectural than on purpose. Like, I don't think it was designed that way on purpose. It really started with because we had to have an IP address to be able to DNS to find,
Yeah.
where all this stuff lived.
Well, I think that there's a lot of systems where computer A and computer B are part of the same system, and that we don't have to, and therefore a lot of APIs don't have to bear a compatibility burden. They can just say, "Oh, I own the caller, I own the recipient. Okay, let's just make it for us." And so in that case, I wonder if the type of API that we should be trying to design is one that pushes the contract a little bit into the receiver, just like the asynchronous queues are, where I'm going to send multiple message types to the same queue, and then the process that's listening on the queue is going to say, "Oh, what do I have? Let me route it." And whereas web service APIs, the routing is front and center in the URL versus just, "Hey, let me call a URL that knows how to receive a lot of different JSON, blobs, and then let me have the receiver behind that API say, oh, which JSON did I get? Okay, let me send it where it needs to go and let me get the answer back." What's your opinion on that style?
I think that style is perfectly appropriate, but the same work needs to happen somewhere. Does that happen from the client, or does it happen behind the scenes, or does it, I I think that is perfectly appropriate for a lot of situations. And again, this notion of, I think you're going to have a bit of both. Like, when I make a request to find out the current price of a stock, I need to know what that price is right now. I can't wait for the queue.
Right.
But if, we had this, I worked for a company called Delphi Forums many years ago that did, all these people come in and put comments in. And we separated creating a new message from marking a message read, because if we lost that a message was read, we weren't as concerned as losing an entire message. And I think you see that in a lot of enterprises. Like, this is important information that we have to make sure gets saved.
Yeah.
If we lose a couple of these messages, okay, that's not important. Or if they get deferred, more importantly, because we're not really losing messages, but they get deferred to, 20 seconds later, does that really matter? That allows us to scale that a little better than that. But I think we're running into that same thing with APIs that we ran into with SQL and NoSQL, and that is, people understand relational databases, and so they were slow to sort of adopt NoSQL. And I think we're seeing that same thing with APIs. People are so used to it being connectioned that doing something like queues or buses is just taking more time me included, right? My initial instinct is not to create a queue and to have more things in the data center, and to my detriment sometimes, right?
Yeah. And you made a good point about I guess, guaranteed delivery. Because you mentioned SignalR. Do they have a guaranteed delivery configuration, or is it purely guaranteed or delivered sometimes?
Delivered sometimes is my understanding. I'm sure someone SignalR will go, no, there's a way to do that. But I get a lot of calls about helping people solve that problem, because it is difficult. And in many ways, SignalR may not be the right solution for when you need guaranteed delivery, right? Something like a queue makes a lot more sense for guaranteed delivery, and can deal with connection lists and some other things.
Yeah. Regular listeners of the podcast kind of hear me talk about one of our clients that does auction software, and notification of a new bid is one of those things that routes with SignalR. For all the people who are watching a particular lot on an auction, a bid comes in, it's like being near instantaneous delivery that price just changed for the people who are looking at it. But it's not the end of the world if something happens and that notification doesn't make it.
Because you can't have everything. Do you want guaranteed delivery, or do you want near real time that you're getting from SignalR? And the reality is, what makes one work really well may not fit the other one? So do you want it slower so you get guaranteed delivery? Like all those are architectural decisions that not only are happening inside of our applications, but also happen when these libraries were built.
Mm-hmm.
Yeah. And so we have to understand where things are better or worse architecturally, and decide which ones we want to use.
Yeah. So as we close up, just to end your in the weeds question, what's your current favorite JSON serializer? Some people are kind of lament, oh, I can't get the dates working, or this or that, or everybody has serialization issues from time to time. So
I still drop down into JSON.NET. I still don't quite trust the new ASP.NET stack for doing it. It's worked so well for me for so many years that I tend to not want to move. So it's one of the first things I do to a project when I start a new ASP.NET project is bring in the JSON serializer and opt out of the system.json. I'm sure someone at Microsoft will send me an email as soon as they hear this, and we're like, but
so which one? The Newtonsoft JSON.NET?
Newtonsoft JSON.NET. Yeah. I still JSON serialization should be a commodity, and if I have to think about it, there's something wrong.
Right. Well, awesome. Hey, this is a lot of good information, and I'll encourage the listeners to go and look at the recent recorded talks. One of the big ones from .NET Conf 2021, our real world APIs. Check Shawn out on Pluralsight and on even helloworldfilm.com. And is there anything else, any other resources that we should send the listeners to?
Yeah, I have a YouTube channel where I do rants as well as these things called coding shorts, which are about 10-minute coding tips. You can find that at ShawnL.ink. So Shawn Link with a period in it /YT for YouTube.
Awesome. ShawnL.ink/YouTube.
YT.
Just YT.
Yeah. I think YouTube works as well, but
yet another top level domain extension. Okay, now I need to go buy my name.ink.
Exactly.
There's so many out there.
There are.
Awesome.
There are.
Well, hey, Shawn, thanks for spending the time with us and coming on the show.
It's been a lot of fun.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.